Hello, I'm Luis, and I'm recording this video to show my solution for the time traveling data structure problem. And yeah, I will quick cover the summary of the problem and then discuss some practical scenarios for this data structure, thinking in the real world for this problem, and then implement the optimized solution and discuss some things about time complexity. Okay, so let's do it. I would choose Python to do this challenging because Python is my primary language. So here's our description for the problem. I'm not going to read it. I will assume that everyone who's seen this video already knows this problem. And this is a very common problem on LeetCode. And actually at interest one because we need to shift from thinking in traditional data structures to thinking our own data structure. And he says that he wants one that allows you to travel in time. This is a very abstract way to thinking in a data structure. And yeah, and when you try to when you try to think in practical problems, this could be actually helpful because, for example, imagine if you have a workflow of contracts and these contracts change 5 or 10 times over the year, and your clients wants to know how this contracts looks like in 1 month ago. So you could use this data structure to retrieve this value, and you just need to pass the timestamp. So this is a good approach and a good way to see this data structure. Also, for retrieving logs in maybe CloudWatch on AWS, you still have to pass a timestamp to retrieve a range of messages of your system and debug your system. So also a good example. I, I use quite a lot this type of data structure in my day-to-day work because working in a financial company, every day we need to retrieve interest rate values, and we don't want just the value for the specific timestamp. If it doesn't exist, we still want the most recent one before the timestamp that we're passing. So yeah, that's why I could understand better this problem. So let's start to implement. So last time traveling. Yeah, that we need. Our first method is always the init method. So here we need to add in our main data structure. And this could be a simple dictionary. I will choose the default dictionary just to make the things more clean code, so more understandable, the code understandable. So because for default it, we can pass the type of our values for the for the dictionary. So default it. For this problem, we have to implement two main operations: the put to add in things in our support dictionary, and the get to retrieve the most recent values before the timestamp was given. So let's implement it. The put is the easiest part. Let me just finish recording. So okay, the put is the easiest part. Uh, we just need to add our key and our value in the list. So let's add it. Here is where we see the best benefits to using this approach, because our code is more simple using this method is actually more simple using this type of approach for dictionary. So yeah, let's just add a comment here to make the thing clear. Also, let's add a comment here. Yeah, one thing that I forgot to mention is the tuples. We choose tuples because tuples fits very well in the practical scenarios. Tuples in Python are immutable, and timestamps and uh, informations about contracts and informations about logs are also immutable. So tuple is the best approach here. So yeah, let's move forward to the interest part. So take that. One way to solve this is simple. So I could just add every key in a single list and iterate through this key and get the most recent value. But it's quite slow and requires O of n, time complexity, and uh, yeah, maybe from perspective, searching through 1 million of informations or 1 million of logs maybe could be extremely slow. So this is not a good approach for this. So in a financial applications, maybe where milliseconds matter and historical data can grow to millions of entries, this approach quickly becomes impractical. So it's not a good way to solve this problem. And the best approach here is actually use binary search. Binary search is the best way to solve this problem and reduces our time complex from O of n to sorry, O of n to O log of n. So this is much faster. And yeah, how this works. So the idea here is always dividing our list into separate parts. The parts that is lesser than our timestamp is smaller than our timestamp, and the part that is bigger than our timestamp. And in every iteration, we could actually reduce this list in half. So divide the structure in the middle and divide it into parts in each iteration until we find the the right timestamp for the given parameter. So yeah, let's implement this. So first we need to see if our key exists in our map. So first in map. If it doesn't exist, we don't need to return nothing. So now let's retrieve our list to pass for the binary search algorithm. So let's make a helper list here just to use only use the timestamps. I think this could be more a clean approach to this problem. So Yeah, I think that's it. We, we are iterating over the list and getting just the timestamp. So I is the timestamp and V is the value. So quite simple, right? It's just a comprehension list in Python. It's comprehension in Python. So now let's actually make the things work. So let's implement our binary search. So we have this, um, how can I say this inbuilt function Python. So inbuilt in Python library. So bicep bicep. Let's import this. The first parameter is our list. So and the second parameter is the timestamp that we want. -1. The -1 is from the formula, so it's kind of a pattern here for the binary search. So if it's 0, we just have to return our value. So we could return the value using this approach. So EDX. Let's retrieve the second value here. And so this is important because if this part is lesser than 0, is a negative value, it means that any value is smaller than the timestamp that is passed, so we just have to return also. Yeah, so let's put some comments here just to make the things clear. So here we are trying to find the rightmost timestamp, right? Given timestamp. The approach that we want to make in this listen is written in the description. And yeah, okay, I think that's it. Still, the time complexity here is O log of n, so it's way better than O of n. The space complexity, it's O of n because we still need to store our list from the timestamp and our list from the values here. So this list increases in the same proportion of the list of timestamps. So this is actually O of n, O of n. Yeah, I think that's it. That's it. This is the implementation. And let's just write some examples here. So let's put 50. So time traveling HashMap. This is our listed complete instruction. Yeah, okay. Let's bring this the get part. So and see the things working. So yeah, now let's try to run this thing. So all right, so everything looks good, and this is the right values. So yeah, I think that's it. And thank you to follow me in this solution. Mm,